These are two technologies related to supercapacitor based energy storage system. But in Kilowatt Labs technology, it was developed around supercapacitor to make the supercapacitor work like a battery. So all the control systems, balancing mechanism, everything was built in an electronic circuit board. The firmware was burnt into it, which was managing four things like balancing supercapacitors on the same speed they get in balance. Then the second thing was, making the voltage curve flat. The third was retaining charge inside the supercapacitor. So charge retention was the third thing, and the fourth one was the energy density. So everything was around supercapacitors, and the electronics was managing it. Even for the charge management, we embedded 6% lithium-ion component inside the supercapacitors. We specially ordered. But primarily, the technology was around supercapacitors, and it was working in a way that it was using supercapacitors as a storage media and to make them work like a battery. While ENERCAP is actually the short form of encapsulated capacitor. It's a supercapacitor technology, and it's a supercapacitor which does not require any external control. It does not require any technology around it because the cell itself is a digital cell. So the ENERCAP technology is the supercapacitor technology, while Kilowatt Labs series technology was around supercapacitors to make them work like a battery. So I think this concept should be clear now. So the most daring project this year we came across is a 20 megawatt hour utility scale energy storage system. The project is very aggressive. It has all the technology tests and technology validations in it, because it's a microgrid, grid forming energy storage system at a utility level. A system has multiple functions and features which we have designed in here, we have developed in here, and right now we are in a process of manufacturing it, and we are super excited that very soon we are going to deploy in the utility scale industry. And I am sure the project, once it is deployed, will change the whole mindset of industry related to energy storage systems. So utilities recently has started using energy storage system, which is a remarkable change, because initially utilities were doing generation, transmission and distribution systems, and this can be managed easily by just optimizing the whole infrastructure with the implementation of energy storage system. And with these type of efforts utility has started, I think the grids will be optimized. They will be ready to take renewable energies much more efficiently than before, and the industry will get, you don't have to invest a lot of money only in generation, only in transmission and in distribution, while you can manage all these shortfalls by just implementing energy storage system more efficiently in distribution networks, in transmission networks, and obviously generation networks as well. So I think very soon world will see a different design of utility with the implementation of energy storage systems. So electrostatic storage has so many added advantages on chemical storage. We are fighting a battle for saving our lives from chemical reactions all around us. The carbon footprint, that's one of the repercussion we are getting from these chemical reactions. So electrostatic storage does not require any type of chemical reaction. They are non-toxic. They have very long life. They have high response time. they have much more high efficiency, round trip efficiency than any chemical battery can give. They do not get degraded when used under high or low temperatures or over a period of time. So every chemical reaction has a decaying process, has so many associated problems. While electrostatic is not only green, it is more efficient and it is more reliable, and it is longer life. It carries long life as well. Let me start from the beginning. When uh, I entered into this industry, or I invented the technology, we were raising money, and in my first investors interview, they asked me, when do you anticipate the first competition? So at that time, back in 2015, I anticipated that we may expect a competition within 5 years. It's been 8, 9 years. They are popping up, but you need to understand. First of all, I have no problems. I think competition will build the industry. There should be a healthy competition in any business in order to have healthy competition. Plus, it builds an industry and it gets value for the customer as well. And we are waiting for that time, frankly speaking. But yes, everything has an process, and it's an evolution process, and we think we are passing through that. There are so many supercapacitor manufacturers for so many years, but they manufacture supercapacitors which can be used for the power applications. We were the first one to use them for storage applications. So a device which was designed, developed, and manufactured for power application, we built a technology around it, and we used it to work like a battery. Means we changed the application to storage application. Then we found it necessary to build a supercapacitor for storage application as well. And in ENERCAP we developed that, and that's where the technology is leading now. We anticipate people will come and they will develop technologies. We will have healthy competition, but so far I can see a lot of companies popping up. We hear people are developing technologies, but we are waiting for them to come in industry and have a good competition. One more thing which we really worked on was all the supercapacitor technologies which are readily available in the market today, have the biggest disadvantage of cost. That's another thing which we worked on, developing something which is cost effective, which gives you all the functions and features of a supercapacitor, and which is reliable in operation. So with the passage of time, we are improving it day by day, and today with the supercapacitor technology, we are able to compete the chemical battery market with an electrostatic battery, which we call it supercapacitor based energy storage system.